Okay, hey, this is Dr. Mitchell, and again, we're going to look in this video how to actually perform the force plate analysis on data we obtained from doing a counter movement jump. And so what I've done, I've opened up our BTS Smart Performance software, and you'll need this to be able to do this analysis. And similar to other BTS software, there's kind of a similar progression as far as how we'll deal with our data. So I'm going to starting with our subject. Now we're going to assume this is a new subject, that we haven't had this person in our lab before. If we have, we would need to go find them. But in this case, we're just going to go to new subject. And I'm just going to type in a generic name here. We'll just call it first name test and last name subject. Now you will need to know their date of birth. And so we'll just put in just kind of a random date here, and whether they're male or female. And this will be a male subject, so we'll hit add subject. And now we've added our subject into our database. And now any trials we do afterwards, we can refer back to that subject. We then go to new session. Now we can call this session whatever we want. For this, we'll just call this jump 1, for lack of a better term. If you like, you can give this an actual sport or an activity it is. It doesn't really matter, but jump is fine. Then you want to choose your protocol. So for our counter movement jumps currently, we use the podium_CM jump protocol right there. So podium_CM jump, we put that there. And then it's now going to ask us for anthropometric measures, more specifically the height of our subject in centimeters. So we want to make sure we know their height in centimeters. So we're assuming we've gotten their height, we can convert that to centimeters. And so for our subjects, we're going to put in, just so happens they're 180 centimeters, so we'll put that in. Okay, so once we have that information, we can put that in our new session. Now we're going to go to new trial. Now here is where we are going to import the jumps, more specifically the TDF files that we have already recorded. And so I'm going to go down to browse TDF file. And now here's the point where you just have to know where you put your file. And so I actually know we put in our desktop in sample data, and I actually set up a couple tests just for this. And so I'm going to upload them one at a time. So we'll go to my first one. We'll upload that. It's going to ask me if I want to add any notes to it. I don't, so hit cancel. I'll go to my second one, and I can keep doing this over and over again. I won't add any notes to that. I'll go to my third one. And again, however many jumps you have, you put them in there, that's fine. So I just have 3 jumps. So I'm done with uploading that. I'm gonna hit close. And now I need to import those jumps into my testing frame here. So I'm just gonna hit this little select button with the blue triangle, and that's gonna import them into my trials to be processed. And now I can really dig into doing this analysis. So I'm gonna go over to the right of the screen, and I'm gonna hit this icon here that's gonna allow us to begin to do analysis, and you'll notice a new screen pops up. And this is where we're gonna begin to tell the software what every part of the jump is. Again, software, it's just analyzing force data in the X, Y, and Z axis. It doesn't know what a jump is. It doesn't know phases of jumps. So we need to give it some markers for what some key phases of the jump are. So the first one is toe off. And so the toe off should be at a point right when the individual left the force plate, or in other words, right when the newtons, we measure force in newtons here, is 0. And so typically the software is gonna do a good job at finding this, and it'll provide you an orange line to tell you what it thinks this line is, or this point is. And it just so happens it's right, and I'm pretty good with that. So I'm gonna go along with that. So I'm gonna hit OK. So now I'm gonna go to my second jump, ask me the same question. Again, I'm okay with where that is, so I'm gonna hit OK. My third jump, again, I'm okay with that location, so I'm gonna hit OK. And now it's gonna move to toe strike. So this is basically when the subject is now landing at the end of their jump on the force plate. And so this is the first one. This one's okay. I'm actually gonna move this just to do it. So I'm gonna actually right click on the orange line. That's now gonna remove that marker. And I'm gonna move it where I want it to, and I'm gonna barely move it, but just a little bit. That now becomes blue, but if I move this scrubber up top of the screen here, you'll notice that it's become orange. And basically what I've done is I've created a new marker. And so now this becomes the toe strike. And I'm okay with that. It's a little more accurate than what was previously there. So we'll hit OK. We'll go to our next one. Again, kind of the same thing. Truth is, that's fine. I'm going to move it just to move it. We'll put it right there. We'll hit OK again. Our third one, I'm okay with the third one. That one looks fine to me. So we'll leave that. So we've now done our toe strike for all 3 jumps. Now it moves on. Now it's going to ask for the counter movement start, or to be more specific, this is basically when did the person start to move in the jump. And so this is going to be when at the beginning of the jump when our newtons go from 0 and they start to become negative. Now, if your subject was moving a little bit before the jump, this can be a little hard to do, but if they stood perfectly still before the jump, usually the software is good at picking this up. And so this marker is really good on this first jump, so I'm okay with that. We're gonna hit okay. Here's our second one. I'm okay with this one as well. That's a really good one. Here, the subject really did a good job of standing still, so I'm very good with that. And here's our third one. Again, I'm really good with this one as well. So that looks pretty good. So I'm gonna hit okay with that. So those 3 were all pretty decent for the most part. Okay, so the next one it's gonna ask for is what's called J-stop, or more specifically, when did the landing phase end? And basically this is at the end of the jump, after the person has landed, when the force in newtons returns to 0. And now this can be hard sometimes if the person has an unusual landing, if they land stiffly. So this can be a tough one sometimes, but as long as we're kind of close to where it is, this is actually a very good one, right? You see on the screen, that's a really good marker. So I'm okay with that. We'll hit okay on that. This one, you notice this one looks a little bit different, but again, that is, the marker is right when that force in newtons drops to 0. So that's quite good. I'm good with that marker. And again, here's our third one. I'm good with this one as well. This one looks pretty good, so I'm gonna hit okay with that. Awesome. Now the next question is gonna ask is, when does the concentric phase of the jump start? Now, at this point in analysis, all of the information it wants to know should work okay. I mean, if we get the first 4 markers right, toe off, toe strike, beginning of the jump, end of the jump, it should be able to put the other pieces together. But if there is going to be a problem, it's often here. And so what I want is I want the marker to be at the point of, and this is in speed, if you notice it's in meters per second. Now we're no longer in newtons, where this goes from negative to positive meters per second. And this is the shape of this curve. It should look very much like this. If it doesn't, there's probably an error in the data. You probably want to start over or just remove that jump totally. And so this is a really good marker. I'm okay with where the location of this one is, so I'm gonna hit okay. The second one's good, which is, yeah, very good with that, so I'm good with that. We'll hit okay. Our third one is good as well. Now, I will tell you occasionally when I'm doing analysis of these, if I'm gonna see an error, oftentimes this orange line will get moved up towards the beginning of the change in acceleration and velocity, so you're gonna need to move that. But this is really the location you want to have this marker in. So again, I'm okay with this. And at this point, all the other analyses should be correct. If you've done these 5 steps right, 99% chance everything's gonna be okay. So at this point, we're just gonna hit okay a lot. And we're gonna basically tell the software, hey, we're okay with this marker. And it's going through different phases, different aspects of the jump it wants to know. This is the positive eccentric phase. Now it's asking for when was the start of power development. Again, you don't have to know exactly what these terms mean, because again, if we've done this analysis correctly, we've done the markers correctly, the software should be able to figure this out. Here it's coming up with peak power. So there's a peak power measure. Those look good. So we're good with that. This is peak anterior force. So this is in the anterior plane, posterior plane here. Again, we really don't use this data a lot, but we're just gonna continue on. And this is now where it's gonna calculate based on using some basic calculus. It's gonna calculate jump height. And again, all of this should be okay if we've done everything up to this previously. And so you'll notice, again, I'm hitting okay a lot here. It does get a little bit tedious, but to make sure we have accurate data, we want to make sure we're going through all of these. So all of these are okay. That's good. And then we're nearing the end here. These are interior forces and landing. Again, not terribly important in our final analysis, but looking good. Great. So we've analyzed our data. We're going to go up to the top of the screen and hit save. So it saves this analysis. And immediately this is going to bring us back to the original Smart Performance software. And you'll notice what it's done is taken our jumps and moved them into the third frame here, which basically is saying, hey, we've analyzed the data. Let's now make a report. And so we're going to go to the right of the screen, hit our report icon. And again, new screen will open up. It's going to quickly form a report. This will take a few seconds, so give it time to do that. And once it does that, a new window will open here. And again, this will take a few seconds. That'll give us a preview of what this report will look like. And so what I'm going to do, I'm going to go to print, and we're going to save this as a PDF file. It's just easier if we're going to send this data, email this data, look at it later. Saving as a PDF is just an easier way to do that. So we'll go to PDF Creator. We're going to hit print. And now it's going to ask us, hey, awesome. Do you want to save this? I do. And now it wants to know, where do you want to put this? And so I'm going to put it, we have a folder on our desktop here. We're going to put it in our sample data folder. And we will just give this a title. We will call this just test subject. All right. And again, you can name this whatever you want, just so you know what make sure you know what you've named it. And we're going to hit save. And then in a couple seconds, it's going to show us our PDF file. Now, for most counter-movement jump reports, this is about 4 pages. It goes through some basic information of the subject. It'll go through peak forces in the anterior and posterior components of it. Again, for our analysis, we don't look at this a lot, though it is interesting to know. There would be some pictures here. Just for time's sake, we don't include the pictures. And then we have the last page, and it's really this last page that we are most concerned with. This is where we're going to get our data. For example, power of the lower limbs, which is how much power the subject is putting out during the entire jump. This is an estimate of flight height in centimeters. Now, really important to know, it's just an estimate. It's using calculus and acceleration due to gravity to analyze this in your subject. It's not perfect. The subject does move around in the air, and because of that, this number will not always be correct. We have better ways we can accurately assess that. Another value we look at is velocity at toe off. It's a pretty important one. That's basically the millisecond they leave the force plate, what's their speed. Peak velocity is the peak velocity during the entire jump. And then drop-off velocity, that's simply going to be a percent difference between our peak velocity and velocity at toe off. Basically, it's a measure of the efficiency of this individual's jump. You also notice there's some other data here, leg stiffness, which it measures in kilonewtons per meter, and it gives us a rate of force development in the bending and loading phases here. And there's value to know that. It gives us both absolute and relative values of those for our subject. You also notice at the top of the screen, it gives us percent of force on the left and right leg if we want to know that as well. So again, this last page is where we're going to get our data from. And this is where we're going to use this data and enter it into our database or provide it to the subjects for whatever it is that we are using this data for. I hope that helped. I hope this gives you a better understanding of how to analyze this data. And we will see you in the next video.